last thing we'll talk about today was distillation. So you saw a couple different types of distillation in that video. The first was simple distillation here, and then fractional distillation. So as we saw, distillation separates a mixture based on its volatility or different boiling points. So this really takes advantage of the different intermolecular forces and the different components of a miscible or totally mixed mixture. So the following setup to prepare to separate a mixture of ethanol and water. Explain the purpose of the fractionating column, the thermometer, and the Liebig condenser. Please pause the video right now and see if you can remember what all of those are for. All right, first is the fractionating column. Now the fractionating column keeps the water vapor from rising, so only the ethanol is condensed. All right, then thermometer. Thermometer is used to keep the temperature between the boiling points of water and ethanol. So you want the boiling point to be higher than ethanol, or at least at the ethanol, but below the boiling point of water. That way water stays in the liquid phase. And finally, the condenser cools and condenses the ethanol vapor. So it cools and condenses it, and then only the ethanol drips into this flask. Why is the ethanol collected as the distillate and not the water? What does this tell you about their molecular structures? Okay, so ethanol is more volatile and it's easily vaporized. So we can tell that because it was collected first. So since it's easily vaporized and it came off first, we know its boiling point is lower. Why is its boiling point lower? That's because it has weaker intermolecular forces than water. All right, last thing, that was simple distillation. You could also do fractional distillation, and this is really cool because this is how oil is refined into all of these different things we use. So fractional distillation is used in separating crude oil. So the crude oil separates into various trays, and these are the trays. These are the different levels. So crude oil enters near the bottom of the tower. The heat source is at the bottom of the tower. So we have some like fire or whatever down there. It's hot. Okay, the difference in temperature throughout the column, where it's hottest at the bottom and coolest at the top, allow the various components to condense at various different trays, and you can separate those out. This completely takes advantage of the different densities and the different boiling points and the different intermolecular forces here. So at the bottom here, we can see that you get fuel oil for ships, factories, and then lubricating oils. Diesel fuels come off here. Car gasoline doesn't come off till very close to the top. And then we get 5 to 9 carbon residues that come off, and we use those for various chemicals and to make plastics. Petroleum gas is 1 to 4 carbons or so. And so those are the lightest, and they come off at the very, very top. And those can be captured separately from like lubricating oils with 20 or 50 carbons. All right, that is all you really need to know about separating mixtures. This was the very last notes of the year, so congratulations, you've made it so far. And there is no new material after this point, so moving on next, we'll work on review. All right, have a great day.